Hello friend, this is Shomik Bishwash and you are attending the class of circuit theory and network. So my today's topic is two-port network. So please put a heading that is two-port network. So two-port network, today's topic. So before that, would like to discuss something that what is a type and what is two-port and what is network. So in short, if you can say that network has generally many more types and many more types can be selected by the different parameters of the network. So a network should have different type of parameters. Now first question is coming that what is the linear and what is a non-linear network. Now in a particular network, if such element is there which is not varying by the changing of that current and the voltage, so obviously that type of network is called linear network, having some linear elements like resistance, capacitance, inductance, like this. But if some other element like transistor, diode, etc., if it is included inside that particular network, so obviously that network is not linear, then it is called the non-linear network. So on the other hand, the network can be again divided by two major parts. One is called that unilateral and bilateral. So unilateral and bilateral, what is the type of such network? Unilateral means in a particular type of network, suppose if it is a network, so suppose it is a current flow. Now suppose the current is flowing in this direction, that is I. Now if the current is flowing in the reverse direction like minus I, so obviously if the value of that particular network element is remain unchanged, so this particular element is called the bilateral element. But if due to the reverse changing of that current, that value of that particular network element is found to be changed, this is called the unilateral element. So in the same way, in a particular circuit, if the parameters of other one is remain fixed, so obviously this particular network is bilateral network. But if due to the changes of the direction of the current flow and the voltage in a particular circuit, if the circuit behave in the something odd or different way, so obviously this circuit is called the bilateral circuit. So what is the difference between unilateral and bilateral? That particular thing is depending upon the behavior of a network element. Okay, why the behavior will be changing? Because the direction change of that input current and the voltage, that is a major thing of this. Now here we are coming to this two-port network. So what is it is called that it is two-port network. Now two-port means one particular box like structure, it having two lines like this and like this. So 1 2 3 4, so all total 4 lines are there. 1 2 3 and 4 lines are there. So this is called that input and this is called the output. Or if this particular element is engaged in a particular network, so this particular part is connected to that source and this particular part will be added to the destination, and the destination can be used again in the source, so they can be combined in one after another, they can be connected. So therefore different type of connections are there. One is called the series, another is called the parallel. Okay, one is the series, then parallel, then cascade. Mainly these three type of connection is available in our two-port network section. So okay, this is a port. So if one particular network having only one source side, it means 1 and 2 is present, not 3 and 4. So this type of network is called one port network. So right in our two-port network chapter, so we have different sort of parameters. So what are the parameters? They are Z parameters, Y parameters, ABCD parameters, inverse ABCD parameters, H parameters and G parameters. Here ABCD parameters and ABCD bar, these are the inverse parameter. In the same way H and G, they are inverse to each other. In the same way Z and Y, they are inverse to each other. Okay, so now in our today's class we will discuss upon only two basic parameters. One is Z and another is Y. Okay, so what is a Z parameter? In that Z parameter, the voltage and current relations are there if in a particular two-port network. As you can see, if this is a input and if this is a output, so obviously the input side is 1, output side is 2. So if it is V1 and if it is V2, that voltage, so obviously it can be written by that Z parameter that V1 V2 using this particular matrix Z11 Z12 Z21 Z22 of that I1 I2. So what should I write? That V1 equals to Z11 I1 plus Z12 I2. What is V2 then? V2 equals to Z21 I1 plus Z22 I2. Okay, so this is the expression of that Z matrix or the Z parameters. Fine. So what is then Y parameter? So if you are writing this Z parameters, actually how to write that? You see, this V1 is a summation of that Z11 I1 Z12 I2. Okay, so here if this is V1, so there is one impedance, that is Z1, but one voltage source is there which is Z12 I2, or you can say it is a current source there, and in the other section there is still one, that is Z21, sorry, that is Z22, and that is Z11, and here the same source, it is Z21 I1. Okay, so that is V2. So it is a current source. In this way it can be formulated. Now if we are using that Z matrix and Z parameters, so what is the Y parameters then? Y parameters, if you want to use, then it just look like this. This is the basic formulation of Y parameters. So how it is activated in the circuit? Because this is say A point, this is B point. So if the current is coming as I1, I1 is dividing itself in this way, that is I1 dashed and I1 double dashed. Now if it is I2 entering from this side, it is also taking two division, that is I2 dashed and I2 double dashed. So what is the current through this branch? That is I1 double dashed minus I2 double dashed. What is the current of this branch? That is I2 dashed. What is the current through this branch? That is I1 dashed, and that branch having I1 and this branch having I2. So these all are the parameters. So how Y parameters can be written in this form, that I1 equals to Y11 V1 plus Y12 V2, and I2 equals to Y21 V1 plus Y22 V2. that is a representation of that y matrix or y parameters. Now it is said that the z parameter is basically representing the T circuit and the y parameter is representing that pi circuit. So z parameters to y parameters conversion is basically star to delta conversion. So any sort of star connected load, why it is look like such things in that delta connected load, already I have shown you in my previous classes. That may be raising a good question in your mind, so you please come to this particular two-port network chapter and that problem will be solved. So here, how to express this in either terms. Say what is the value of Z11. Now Z11 equals to V1 by I1 for I2 equals to 0. Now what is Z12? Z12 means V1 by I2 for I1 equals to 0. In the same way, Z21 equals to V2 by I1 for I2 equals to 0, and Z22 equals to V2 by I2 for I1 equals to 0. Okay. Now this is a basic condition of that z and y, they are interchangeable. How we can make it, say that is I1 I2, so I can write it in this way. You have to just make it free. So how to do this? Say V1, if you are multiplying by Z21, and that is Z21 V1 equals to Z11 Z21 I1 plus Z21 Z12 I2, and that is Z11 V2 Z21 Z11 I1 plus Z11 Z22 I2. So subtracting them, cancelling out, so it should be Z21 V1 minus Z11 V2 divided by Z21 Z12 minus Z11 Z22 I2 equals to 1, or Z21 divided by Z21 Z12 minus Z11 Z22 into V1 minus Z11 of that same Z21 Z12 minus Z11 Z22, or I1 equals to, you can write it as delta Z, Z21 by delta Z V1 minus Z11 by delta Z into V2. Now here one minus is coming. If you are comparing these two, I hope you can see, if you are comparing these two, one minus is coming. So one coefficient I can write it as y11, and here plus of minus we are taking, so that is called that minus Z11 by delta Z, that is called that y12. I'm sorry, I'm just doing it, it's not I1, it's I2, so it should be y21 and that is y22. Okay, that is y22, it is bottom one. Okay, so that is in short of that two-port and y network. Now let us have some numerical problems on this. Now we are discussing some numerical problems on that z parameters. So first of all we can write one T-shaped circuit, and finally we should have to connect that Z parameters value of this particular circuit. So let me have one example first of all. As you can see that one circuit, here one resistance, here another resistance, here another resistance, like this. So there are 5, 12 and 3. Here is 5, this is 12 and this is 3. So this is say VA, this is VB. So you have to find out the Z matrix. So how to do this? So first of all, when you are finding Z11, then you are putting this condition, actually this branch is not having any sort of current. So we should have that if it is 0, so if I2 is 0, it means this branch is 0. So obviously what should I write? If this is I1 and if this is I2, so here it is Z11. For you should write that VA equals to 5I1 plus 12. Here is I1, it is I2, so it is I1 minus I2. And in the other set you should write that VB equals to, in the same way, that 3I2 plus 12 I2 minus I1 equals to this. So now if you're having this type of equation, so that is VA and VB, so that is a Z parametric equation. So you can easily find out that 5I1 and 12I1, so it is 17I1 minus I2. So V1 equals to AI1 plus BI2. So what is the pattern? That is a Z matrix. So V1 equals to Z11 I1 plus Z12 I2. So here you can easily find out what is Z, and by the coefficient of I1. The coefficient of I2 means minus 12 is basically Z12, like this. So you have to find out the entire mathematical problem in this way. Now we should jump for the next other problem, like one pi shaped network can be given, like we have that problem here. It is 1, it is 2, it is 3, it is 5, and this terminal is open. So you have to find out the Z parameters from this circuit. So it is 1 and that is 3. So how to do this? First of all, you can see this is a pi shaped circuit, so either you can convert it into that delta form, like start to delta convention. You can change it in this way. So the entire circuit will be look like this: first one, then the second one, then the third one, and then the fourth one. So if it is, say, what is this equivalent resistance? That's the start to delta convention you have to use to find out this equivalent resistance, as I have discussed in my earlier lecture. Then you have to replace this value RA, RB and RC. So follow the same way to solve this particular problem, that is question number 2. Now in the other way you can have some more question, like question number 3. In question number 3 they will be giving that you have to solve, that is 10, that is 5, again this is 10, again this is I1, and that is I2. So this is I1. So you have to solve this. How to solve this? Now first of all you have to find out the equation. How to do this? Say if it is V1, so normally you can write that V1 equals to I1 into 10 plus 5, and here it is another circuit current, so it is maybe 5 I2 dashed. Okay, 5 I2 dashed. So now if this particular portion, actually when you are finding out the Z parameter, so this portion is open, so no I2 is there. So I can write that here, that minus I2 what you are considering, that is basically the I1. So here I can write that I2 dashed equals to minus I1. So just put this, so you will be getting that plus 5 here. so 20, so V1 by I1 equals to 20 ohm, so that is Z11. Okay, so how to get that Z12? Very simple way. If you are considering from this side, so obviously it should be I1 minus I2 dashed 5 minus 10 I2, so it should be that is V2 equals to I2 minus I2 dashed into 5 minus 10 I2. Considering this particular loop, if you are watching in this way, from this particular section, so it is 10, this is 5, so coming in this way, and that is I2, so minus 5, so this is one reverse flow like that. So using this particular convention, I can again write that it is I2 means that is the reverse of that, no I1 is there, so finally I can write that is I1 plus I1 that is I1 plus I1, so that is this is I2, so it is 10 I1 for this, and this is 5, so here it is plus, so it is 20 I1. Okay, so V2 by I1 equals to 20 again, that is equals to V2 by I1, so that is Z21. Okay, so I have got two values, Z11 and Z21. so how to get that another value? So you have to use the circuit in a different way, so you have to get that Z22. so how to get that Z22? Z22 is only that Z22 here, if you are considering this is the only short circuit current here, so I can write that Z22 equals to, that is 15, and that is 15, and that is I2, so Z22 equals to if you are taking, so it is that is V2 equals to 10 plus 5, that is I2 dashed here, I2 dash means I2, so that is equals to 15 I2, so it is V2 by I2 equals to Z22, so this is 15. You have to find out in this way what is the value of Z12. Okay, so that is a question you may ask from that pi and t section of that Z parameters and the Y parameters. So in this way, in the next class we will discuss on that ABCD parameter and the inverse ABCD parameter. So that's all for this today's lecture. Thank you very much. See you in the next class. Goodbye.